Hello everyone. Today we are going to do the third class in chapter 2. Here we will learn about the different quantities of speed further, like velocity and acceleration. These two quantities we will look today. So first quantity is velocity. Now what is velocity? That could be a good question. The last class we learned about speed, but this quantity, velocity, is quite different. Velocity is a vector quantity. So, as it is a vector quantity, it has two things, both value, that is magnitude, and direction. Clear? So, vector quantities are actually two types. They have two things, magnitude and direction, and velocity is a vector quantity. So the definition of velocity is given: the amount of displacement, because displacement is a vector, not distance. The amount of displacement per unit time is called or is known as velocity. Clear? As velocity is a vector quantity, velocity depends if the object is changing its direction during motion. Even if the object changes its direction, the velocity changes. Clear? That happens because if an object changes direction, its displacement also changes. If an object changes direction, its displacement also changes, and as velocity is displacement by time, hence also velocity changes. Let's see more details. Now the value of velocity, I have called it the amount of displacement per unit time. So velocity is displacement by time. Clear? Velocity is represented by v. Displacement is more given by r, or also you can use d, but I don't use d because d is used for displacement, and t for time. This is my formula of velocity. Clear? Let's do some numericals on this formula. Now, if an object travels, or better to say it displaces, because have a displacement of 30 meters in 5 seconds. The displacement of the object is 30 meters in 5 seconds. Then the velocity, calculate the velocity. Can you do that? The object has a displacement of 30 meters in 5 seconds. So displacement is given, time is given, 30 and 5. So let's start the numerical. Now my formula is velocity is equals to displacement by time. Here displacement r equals to 30 meter and time t equals to 5 seconds. So velocity v equals to r by t, that is 30 by 5, that is 6 meter per second. Clear? And if you get more numericals like this, you will solve using the single step formula. Now just like there was speed, uniform, non-uniform, we have also uniform velocity, non-uniform velocity. But see, I just told you earlier that Velocity is a vector quantity. It is not like speed, it is different from speed. Because as it is a vector quantity, it depends on both magnitude and direction. So a velocity is uniform if the object travels, just like in case of speed, it was traveling at 20 meters per second for all over the time, it is okay. But for velocity, its value needs to be same. But with that, with that, a direction is also required to be same. Its direction is also required to be same. It means if this is an object A and it is traveling with uniform velocity, that means it is not only traveling at the same value, but it is also moving in the same direction. It is also moving in the same direction. That means uniform velocity means the object must travel in a straight path with the same value. Means the value is 20, 20, 20 every second, and also the direction is also same, same, and same. If the object just moving at 20 but moves like this, it also moving at 20 but changes its direction, then the velocity will change. It is no more uniform, but the velocity will become non-uniform velocity. Be very much cautious. Clear? It will be non-uniform velocity. Clear? So this is the concept of uniform and non-uniform velocity. Yes, if it just changes the value from 20 to 30, it is become non-uniform every time. But even if it is changing the direction, it is again becoming non-uniform. So the definitions are very clear now, that if I ask you uniform velocity, the answer is very simple. If an object moves at a constant velocity in a fixed direction, this is very important, in a fixed direction, then the velocity is uniform, or the is called uniform velocity, whatever you write. Clear? And what will be about non-uniform velocity? Let's say non-uniform velocity. You can say that if the object travels with unequal velocities, or its direction changes, then it's non-uniform velocity. Clear? So these quantities are very important. Remember these definitions. Next quantity, after we learn about this, also one more thing is a very tricky part, that an object travels in a circular path like this. What should be its velocity? What should be its velocity? Let's see, if an object is traveling in a circular path, so it starts from point A, and after traveling the whole path, it comes back to the same point. So we know the displacement refers to the straight line distance between the initial point and the final point. But if initial and final are the same points, in this situation the displacement is called zero. The displacement is called zero. and if displacement is 0, velocity is also 0. So if an object is moving in a circular path, or even if it is not circular path, it goes in any direction, but ultimately it comes back to the point from where it started. In that situation also, the displacement is 0 and velocity, as it is displacement by time, so 0 by time, the velocity is also 0. So that's a tricky question. Remember this thing. Now we are coming to acceleration. We know only uniform velocity is not possible, but non-uniform velocity is also occurring. That means the value of velocity changes. Velocity changes. Clear? Velocity can change in a lot of ways, by changing the value, by changing the direction. So if the velocity of an object changes, we have this acceleration. We have this acceleration. If velocity changes, there is acceleration. Okay, or retardation. Also retardation. Retardation means negative acceleration. Means acceleration means speeding up, and means velocity is increasing, and retardation means velocity is decreasing. I will come to this. So you can see that if an object starts its motion at 20 meters per second, okay, I will stand to tell you the definition. Acceleration's definition. It's a small definition. The rate of change of velocity is called acceleration. Rate of change means change in velocity per unit time. Change in velocity per unit time. That means it's quite simple. Means change in velocity by time, and this quantity will be called acceleration. In small I'm write ACC. So it is change in velocity means final velocity minus initial velocity, and that is divided by time, and that is the formula of acceleration. Clear? So if I just express the final velocity by v and the initial velocity by u and time t, acceleration a. So the formula will be very clear to write. Final velocity is v, initial ut. The formula of acceleration is written as a equals to v minus u by t, where v is the final velocity, u is the initial velocity, means the starting velocity, t is time, and a is acceleration. Clear? We can do some numericals on them. Just like if an object starts with 20 meters per second, then it accelerates and reaches 30 meters per second velocity in 5-second time. So the scooter or the car started at 20 in the beginning, that's the initial, and 30 is the final. Clear? So this is u, this is v, and this is t. So initial given, final given, time given, acceleration I know that a equals to v minus u by t. Final is 30, initial is 20, time is 5. So 10 by 5. So the value of acceleration is 10 by 5, that is 2. And the unit is meter per second square. Unit is meter per second square. Why? Why meter per second square? Such unit, huh? The answer is simple. The unit of distance displacement both are meter, right? So speed was distance by time, that is meter per second. So the unit of the speed was meter per second. Velocity was displacement by time. Displacement is meter, time is second. So again, meter per second. Clear? So after we got this meter per second for speed and velocity, we come to acceleration. What is the formula for acceleration? Acceleration is change in velocity by time. What is the velocity's formula? Velocity is in meter per second. The velocity is in meter per second, and again time is in second. So you can see meter by second by s. So it is meter by s into s square. That is why the unit is called meter per second square, because it is twice divided by s. This s here and this s here multiply and become s square. Understood? That is why meter per second square is the unit of acceleration. So these are the things you need to know about the velocities and acceleration. Clear? So see, object's velocity is 22 meter per second to 30 meter per second. Here the velocity is increasing. This case is called acceleration. But always velocity is not increasing. Sometimes it also decreases. Just like you applied some brake and from 50 meter per second the car slowed to 20 meter per second. This kind of case where the velocity is decreasing, that is acceleration is not positive but negative, this situation is called retardation. Retardation and acceleration is very simple, just it's a name. If increasing, then acceleration. If decreasing, then retardation. So that's all we have to do. That's all we have to do in these cases. So this much for today. If you have any doubt, then you can inbox me in WhatsApp. So thank you, class. We will see you next week.